Hello everyone, I am Professor M.V. Sunil Krishna from the Department of Physics at the Indian Institute of Technology, Roorkee. I am also a joint faculty member at the Center for Space Science and Technology at IIT Roorkee. My primary area of research is understanding the space weather modulation of Earth and other planetary atmospheres. I use satellite and ground-based observations of various atmospheric and ionospheric parameters to build a unified understanding of space weather impact on the planetary atmospheres. I am delighted to introduce my online certification course titled Solar Terrestrial Physics, offered through the NPTEL, an initiative by the Ministry of Education, Government of India. This course is going to be a complete introduction to solar terrestrial physics, spanning solar activity, plasma processes, ionospheric dynamics, and their relevance to today's space-dependent technologies. In an era defined by satellite communications, precise navigation, and rapidly expanding space-based infrastructure, the field of solar terrestrial physics has become indispensable. Variability in the Sun and its interaction with Earth's space environment directly affect communication systems, aviation routes, power grids, and satellite operations, making a scientific understanding of these processes crucial for modern technological resilience. This course is ideal for senior undergraduate and postgraduate and PhD students specializing in physics, atmospheric science, space physics, electronics and communication engineering, mathematics, and other closely related disciplines. It also serves as a valuable resource for industry professionals and researchers working in the field of space science and technology. The course on solar terrestrial physics offers a comprehensive exploration of Sun-Earth interaction, beginning with the Sun as a dynamic star whose atmosphere, radiation, and solar wind shape the interplanetary medium. It examines how solar and interplanetary magnetic fields evolve and how the solar wind influence the planetary environment across the solar system. Core principles of kinetic theory and fluid dynamics prepare the students for the fluid treatment of plasmas, including the derivations of governing equations. Building on these foundations, the course develops magneto-hydrodynamic concepts through Ohm's law and ideal induction equation. Attention then turns to the dynamo action and atmospheric motions, exploring global circulation, upper atmospheric heating, and the roles of lunar and solar tides. The ionospheric segment discusses the formation of various layers of ionosphere, charged particle motion, and the conductivity structures that support the ionospheric currents. Students will investigate F-region current drifts, ion drags, geomagnetic indices, storm time processes, and the irregularities that produce traveling ionospheric disturbances. The course concludes with an in-depth study of Whistlers and VLF emissions, including their dispersion characteristics, emission mechanisms, nonlinear behavior, quasi-linear theory, and particle diffusion. To earn a certificate, participants are required to complete weekly assignments designed to reinforce learning outcomes. A proctored examination will be held at the end of the course to assess overall performance. I invite you all to join me in exploring this exciting and evolving field of space physics. Thank you, and I look forward to having you in the course.